Second part of this day, we're going to get into even and odd properties, and we're going to use these for some shortcuts. So jumping to this next page, okay, if f of x is an even function, even function, odd function. We got to go back and think about some things. Even function. Let's see, even function. If I was going to graph out what an even function would look like, I think even functions, if I remember right, had symmetry across the y-axis. So even function. Well, if I asked you to do the integral from negative a to a of f of x dx, here's the opposite of a, here's a. If I asked you to figure out the area under the curve, if this function truly is even and truly has symmetry across that y-axis, then this integral, if I wanted a shortcut, you know how your favorite number ever to plug in when you do a definite integral is 0? Well, this would be the same as doubling half of that region. Well, I'm a big fan of using zeros, and I really like positive numbers better than I like negative numbers. So if it's an even function, I could use just the positive number, start at 0, go to a, and double the result. So that's a little shortcut for us if it's an even function. You'll like that almost as much as when you have an odd function. What's an odd function look like? Odd function has symmetry across the origin. For example, something that looks like this. So if I put negative a here, and I put a here, and I figure out this area, and I figure out this area, if the graph is better than mine is, mine obviously is not drawn very well right here, but with definite integrals, in any region that's below the x-axis is represented with a negative on the integral. So if that's the case, if I'm supposed to integrate from negative a to a for an odd function, those two areas are always going to cancel each other out. So an odd function, if you're integrating an odd function from negative a to a, that area is always going to be 0. So there's two nice little shortcuts right there, but you got to be able to recognize an even and an odd function. So let's look at problem number 3. Problem number 3, notice your bounds. We're going from negative 2 to 2. Same, only they're off by a sign. Well, is this an even function or an odd function? Well, x cubed would be an odd degree, but I don't know that that's an odd function. I guess I'd have to test it, maybe graph it, maybe this, maybe that. Here's what we're going to do. We're going to make 4 functions out of it. We're going to make 4 functions out of this. We're going to split this polynomial into 4 functions. Let's rewrite it. If I wanted to rewrite this function, I could make it the integral from negative 2 to 2 of x cubed dx plus the integral from negative 2 to 2 of x squared dx plus the integral from negative 2 to 2 of 3x dx plus the integral from negative 2 to 2 of 2 dx. Now, instead of asking one question about the whole thing, what about these individual ones? Well, x cubed is definitely odd. 3x is definitely odd. I don't know why I didn't write the 0 first. That's definitely odd. X squared is definitely even, and 2 is even, or it's a nice little number. So you got 2 odd ones and you got 2 even ones. Well, what's the shortcut from negative to integrating negative 2 to 2 of an odd function? This is going to be 0. So is this one. So we've reduced this 4-term polynomial down to 2. And if I wanted to, I could turn this problem into the integral from 0 to 2 of x squared dx, as long as I remember to double the result, plus double the integral from 0 to 2 of 2 dx. And now I've just created a function that is a heck of a lot easier than the one I had before. 1/3 x cubed. I'm doubling it, and I'm going from 0 to 2. Plus 2 times, let's see, that would be 2x, going from 0 to 2. Plug your values in. So this first one, I've got 2/3 times 8 minus 0, plus 4 times 2 minus 0. Clean it all up. 8 times 2 is 16/3, plus 8 would be 24/3, plus 16/3. Put those two things together, 40/3. Now, first off, I would hope if you had to do problem number 3 and you had a calculator, I would hope you would punch it straight in. But here is a nice little technique. If you can recognize that a function is even or odd, you can either cut your work in half or cut it out completely if it's an odd function. So even and odd properties are kind of nice little things to have to make life a little bit easier on us.